Managing uncooperative suppliers is critical for electrical contractors. Firstly, establish clear communication. Discuss the project specifications thoroughly with the supplier and put everything in writing. State the exact parts and materials required, including brand, model, and quantity. Provide a detailed list of the items that you are responsible for and those that the owner is supplying. Secondly, verify orders and invoices. Double-check all orders and invoices against your original specifications. If there are discrepancies, contact the supplier immediately to correct them. Keep a record of all communication and documents related to the order. Thirdly, monitor deliveries. Inspect deliveries upon arrival to ensure they match your specifications. Note any missing or damaged items and report them to the supplier promptly. Document the time and date of delivery for future reference. Fourthly, document all interactions. Keep a record of all conversations, emails, and other communications with the supplier. Note any concerns, discrepancies, or attempts by the supplier to mislead or overcharge. Fifthly, seek support. If you are unable to resolve issues directly with the supplier, contact your local contractor association or licensing board for support. They may provide guidance or mediate disputes. Sixthly, consider changing suppliers. If the supplier continues to be uncooperative or deliberately sabotages your projects, consider finding an alternative source. Get recommendations from other contractors or check online reviews. Preventing future issues is also important. Establish relationships by building positive relationships with reputable suppliers who are knowledgeable about your industry. Review supplier policies by familiarizing yourself with each supplier's policies regarding returns, credits, and dispute resolution. Read contracts carefully by paying attention to the terms and conditions of any agreements you enter into with suppliers. Use online ordering by considering using online platforms that provide transparency and accountability in the ordering process. Seek legal advice if necessary by consulting with an attorney to protect your interests and enforce your contracts. Remember, it is crucial to maintain professionalism and integrity in your dealings with suppliers. By following these strategies, you can minimize the impact of uncooperative suppliers and ensure the success of your projects. When dealing with electrical suppliers, there are several key areas to focus on, ensuring a smooth and successful project. Electrical panel selection is a primary concern. For a 200 amp service, the panel needs to be appropriately sized, typically with a minimum of 40 circuits to accommodate the needs of a 2,400 square foot house. Using a panel with only 20 circuits and relying on tandem breakers, also known as thin breakers, to double the circuit count is often not ideal and may not meet local electrical codes depending on the type of circuits involved. The panel's labeling must be clear and accurate to aid in future troubleshooting and maintenance. Grounding and neutral provisions are critical for safety. The panel must have adequate space and terminals for all grounding and neutral conductors. Using a panel not designed for the required number of grounds and neutrals is a significant safety hazard. Overcrowding the panel can lead to loose connections, increasing the risk of electrical fires or equipment failure. It is crucial to adhere to National Electrical Code (NEC) requirements for grounding and bonding to ensure the electrical system's safety and reliability. Breaker selection is equally important. The breakers must match the panel specifications and be appropriately sized for the circuits they protect. Using breakers with lower amp ratings than required can cause nuisance tripping, while using breakers with higher amp ratings can overload the circuit, leading to overheating and potential fires. The proper selection of breakers, including ground fault circuit interrupter (GFCI) and arc fault circuit interrupter (FSI) breakers, is essential for meeting code requirements and ensuring safety. Wiring and conductor management is another area of focus. All wiring must be of the correct gauge and type for the intended application. Using undersized wiring can lead to voltage drop, overheating, and potential fires. The wiring should be neatly organized and properly secured within the panel and throughout the house. Proper labeling of all circuits and conductors is essential for future maintenance and troubleshooting. The NEC provides detailed guidelines on wiring methods and conductor sizing, and it is critical to follow these guidelines to ensure a safe and compliant electrical system. Surge protection is increasingly important in modern homes with sensitive electronic equipment. Installing a whole house surge protector at the electrical panel can help protect against voltage spikes caused by lightning or other electrical disturbances. Surge protectors divert excess voltage away from sensitive electronics, preventing damage and extending their lifespan. The surge protector should be properly grounded and rated for the electrical system's voltage and current capacity. Furthermore, communication and documentation are key when dealing with suppliers. Always document all interactions with the supplier, including phone calls, emails, and in-person conversations. Keep records of all orders, invoices, and delivery receipts. If there are discrepancies or issues with the materials, document them immediately and notify the supplier in writing. Having a clear and documented record of all transactions can help resolve disputes and protect your interests. Regular communication with the homeowner or client is also essential. Keep them informed of any issues or delays in the project and explain any changes to the original plan. Obtain their approval for any changes or additional costs before proceeding with the work. Transparency and open communication can help build trust and prevent misunderstandings. Professionalism and ethics are paramount in the electrical contracting industry. Always conduct yourself with integrity and honesty in your dealings with suppliers, clients, and other contractors. Avoid cutting corners or using substandard materials to save money, as this can compromise safety and lead to future problems. Uphold the highest standards of workmanship and adhere to all applicable codes and regulations. Furthermore, understanding the NEC is paramount for electrical contractors. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It covers virtually every aspect of electrical work, from wiring methods and conductor sizing to grounding and bonding, overcurrent protection, and equipment installation. Staying up to date with the latest edition of the NEC is essential for ensuring that your work is safe, compliant, and meets the highest standards. The NEC is updated every 3 years, and it is important to familiarize yourself with any changes or revisions that may affect your work. Consider attending NEC training courses or workshops to enhance your knowledge and skills. Chapter 2 of the NEC covers wiring and protection. Article 210 covers branch circuits. This article provides requirements for the number and type of branch circuits required in dwellings, including general lighting and receptacle circuits, small appliance circuits, and laundry circuits. It also specifies the allowable ampacity of branch circuit conductors and the overcurrent protection requirements for each circuit. Article 215 covers feeders. This article provides requirements for sizing and installing feeder conductors, which supply power from the service equipment to branch circuit panels or subpanels. It specifies the allowable ampacity of feeder conductors, the overcurrent protection requirements for feeders, and the grounding and bonding requirements for feeder systems. Article 220 covers branch circuit, feeder, and service calculations. This article provides detailed methods for calculating the load requirements of branch circuits, feeders, and service entrances. It includes guidelines for determining the demand factors to be applied to various types of loads, such as lighting, receptacles, appliances, and heating and cooling equipment. Accurate load calculations are essential for ensuring that the electrical system is properly sized and can safely handle the anticipated load. Article 230 covers services. This article provides requirements for the installation of service conductors, which supply power from the utility company to the building. It specifies the allowable ampacity of service conductors, the overcurrent protection requirements for service entrances, and the grounding and bonding requirements for service equipment. It also covers the location and accessibility of service disconnects and the requirements for service grounding electrodes. Article 240 covers overcurrent protection. This article provides requirements for the selection and installation of overcurrent protective devices, such as fuses and circuit breakers. It specifies the allowable ampacity of conductors in equipment, the interrupting rating of overcurrent protective devices, and the coordination of overcurrent protection systems. Proper overcurrent protection is essential for preventing overloads, short circuits, and ground faults, which can cause fires and electrical hazards. Chapter 3 of the NEC covers wiring methods and materials. Article 300 covers general requirements for wiring methods and materials. This article provides general guidelines for the installation of wiring systems, including requirements for physical protection, support, and securement. It also covers the use of approved materials and equipment and the proper identification of conductors. Article 310 covers conductors for general wiring. This article provides detailed information on the types, sizes, and ampacities of conductors used in general wiring applications. It includes tables listing the allowable ampacities of conductors based on their insulation type, temperature rating, and installation conditions. It also covers the dirtying of conductors in certain applications, such as when multiple conductors are bundled together or when conductors are installed in high-temperature environments. Article 312 covers cabinets, cut-out boxes, and meter socket enclosures. This article provides requirements for the construction, installation, and use of cabinets, cut-out boxes, and meter socket enclosures. It specifies the minimum dimensions of enclosures, the requirements for grounding and bonding, and the proper installation of conductors and equipment within enclosures. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. This article provides requirements for the installation of outlet boxes, device boxes, pull boxes, junction boxes, conduit bodies, fittings, and manholes. It specifies the types of boxes and fittings that are permitted in various applications, the minimum dimensions of boxes, and the proper support and securement of boxes and fittings. Article 320 covers armored cable type AC. This article provides requirements for the installation of armored cable, also known as type AC cable. It specifies the types of locations where armored cable is permitted, the methods for supporting and securing armored cable, and the requirements for bonding and grounding armored cable systems. Article 330 covers metal-clad cable type MC. This article provides requirements for the installation of metal-clad cable, also known as type MC cable. It specifies the types of locations where metal-clad cable is permitted, the methods for supporting and securing metal-clad cable, and the requirements for bonding and grounding metal-clad cable systems. Article 334 covers non-metallic sheath cable types NM, NMC, and NMS. This article provides requirements for the installation of non-metallic sheath cable, also known as type NM, NMC, and NMS cable. It specifies the types of locations where non-metallic sheath cable is permitted, the methods for supporting and securing non-metallic sheath cable, and the requirements for protecting non-metallic sheath cable from physical damage. Article 340 covers underground feeder and branch circuit cable type UF. This article provides requirements for the installation of underground feeder and branch circuit cable, also known as type UF cable. It specifies the types of locations where underground feeder and branch circuit cable is permitted, the methods for burying underground feeder and branch circuit cable, and the requirements for protecting underground feeder and branch circuit cable from physical damage. Chapter 4 of the NEC covers equipment for general use. Article 400 covers flexible cords and cables. This article provides requirements for the use of flexible cords and cables in various applications. It specifies the types of cords and cables that are permitted in certain locations, the allowable ampacities of cords and cables, and the requirements for protecting cords and cables from physical damage. Article 404 covers switches. This article provides requirements for the installation of switches, including SAP switches, dimmer switches, and occupancy sensors. It specifies the types of switches that are permitted in certain locations, the wiring methods for switches, and the grounding and bonding requirements for switches. Article 406 covers receptacles, cord connectors, and attachment plugs caps. This article provides requirements for the installation of receptacles, cord connectors, and attachment plugs, also known as caps. It specifies the types of receptacles that are required in certain locations, such as ground fault circuit interrupter, GFCI, receptacles in bathrooms and kitchens, the wiring methods for receptacles, and the grounding and bonding requirements for receptacles. Article 408 covers switchboards and panel boards. This article provides requirements for the construction, installation, and use of switchboards and panel boards. It specifies the minimum dimensions of switchboards and panel boards, the requirements for grounding and bonding, and the proper installation of conductors and equipment within switchboards and panel boards. Chapter 5 of the NEC covers special occupancies. Article 500 covers hazardous locations, classified. This article provides requirements for electrical installations in hazardous locations, such as locations where flammable gases, vapors, or dust may be present. It specifies the types of equipment that are permitted in hazardous locations, the wiring methods for hazardous locations, and the grounding and bonding requirements for hazardous locations. Article 517 covers healthcare facilities. This article provides requirements for electrical installations in healthcare facilities such as hospitals, nursing homes, and medical clinics. It specifies the types of equipment that are permitted in healthcare facilities, the wiring methods for healthcare facilities, and the grounding and bonding requirements for healthcare facilities. Article 547 covers agricultural buildings. This article provides requirements for electrical installations in agricultural buildings such as barns, poultry houses, and greenhouses. It specifies the types of equipment that are permitted in agricultural buildings, the wiring methods for agricultural buildings, and the grounding and bonding requirements for agricultural buildings. Chapter 6 of the NEC covers special equipment. Article 600 covers electric signs and outline lighting. This article provides requirements for the installation of electric signs and outline lighting. It specifies the types of equipment that are permitted for electric signs and outline lighting, the wiring methods for electric signs and outline lighting, and the grounding and bonding requirements for electric signs and outline lighting. Article 625 covers electric vehicle charging systems. This article provides requirements for the installation of electric vehicle charging systems. It specifies the types of equipment that are permitted for electric vehicle charging systems, the wiring methods for electric vehicle charging systems, and the grounding and bonding requirements for electric vehicle charging systems. Article 680 covers swimming pools, fountains, and similar installations. This article provides requirements for electrical installations in swimming pools, fountains, and similar installations. It specifies the types of equipment that are permitted in swimming pools, fountains, and similar installations, the wiring methods for swimming pools, fountains, and similar installations, and the grounding and bonding requirements for swimming pools, fountains, and similar installations. Remember that this is not an exhaustive list of all the articles in the NEC, and there are many other articles that may be relevant to specific electrical installations. It is important to consult the NEC directly for complete and up-to-date information. When dealing with suppliers, always maintain a professional demeanor, clearly communicate your needs, and document all interactions to protect your interests and ensure the success of your electrical projects.